In section 7.3, we'll be multiplying powers that have the same base. So first thing we're going to do is a little discovery with it. We're just going to write them out, and then we're going to see a pattern, and we are going to come up with one of our key points this chapter. And it's something that's used throughout many fields of mathematics. So we work a lot with exponents, and these rules of exponents are actually very important in classes to come. So in lieu of memorizing them, what you really want to do is understand how they're created. So first with the discovery, keep in mind that the exponent tells you how many x's you're multiplying. In this case 2, in this case 3. And so if we have 2 and then we have 3 more, you'll notice that I have 5 x's. Likewise, now I'm getting more exponents, so there's more I'm going to have to write out, which hence it's nice if I can recognize the pattern and come up with my little property here. So this would be 5 times itself 4 times, and then 5 times itself 5 times. And when I'm all done, and I had 4 and then 5 more, you'll notice I have 9 5s. So you can see a definite connection between the exponent in my answer and the exponents in my original problem. It is obviously a situation where I'm adding the exponents. So when we put this in property notation, this applies for any base. We're going to call that A. And then we have got 2 exponents here. And what did we do with those? We added them. So our first property here is that when we multiply, we add the exponents. But it's very important to note that the bases have to be the same. So a problem like this, you might be tempted to say, well, 2 times 3 is 6. And the root said I add the exponent. So it's 6 to the 4th. That's not what we have here because the 2 is a different base than the 3. Really what I've got is 2 2's and 3 3's. I do not have 4 6's. So be very careful with that those bases are the same before you use the property. This one you would actually just have to multiply out by hand or leave it as it is, but there is no shortcut for that one. So to multiply powers with the same base, a little repetition here, you simply add exponents. Keep in mind, though, that our other rules still apply. What were our other rules? Well, again, some repetition here. We also have that anything to the 0 power is 1. And we have that when we have negative exponents, it means to divide instead of multiply. So what really happens is the negative exponent causes a reciprocal action or causes us to go to the opposite level. So let's apply all those rules in some examples. What do we get when we do 2 to the 3rd times 2 to the 5th? Well, I don't want to write them all out, and I don't want to do what looks good, which would be to say, oh, I just multiply these and it's 15. I'm going to do what the property says. I would have 3 2's and 5 2's, giving me 2 to the 3 plus 5, or 2 to the 8th. It's as easy as that. I simply add those exponents up. On the next one, I'd have x to the 3rd plus a negative 5. I simply add the exponents. That gives me x to the negative 2, but we don't ever leave negative exponents in this level of math and beyond, so we really need to know that this means to divide by x twice, which sends it to the other level. So moving on to the next page, just to give you some common errors to avoid before we go do some practice. Again, first we don't multiply those bases. We say we would have 2 4's and 3 more 4's gives us 5 4's. We don't have any kind of 16s going on in there. So make sure you don't multiply the bases. Next, we don't leave any negative exponents in our answers. We also have to be very careful what's being raised to the negative power, see, because this 2 right here is not to the negative 3rd. This isn't in parentheses. That 2 is really to the positive 1. Again, when we talk about your age, we don't say we're 14 to the 1st power, but it's implied, and you should know that when you have a low number like that, it's to the 1st power. So this is really 2 times x to the negative 3rd. It's this one that's to the negative power. This one's to a positive power. It gets to stay upstairs while we send the x down or divide by it 3 times. Next step, be careful you are very clear with what I said to add. I did not say add the coefficients, and then the obvious question would be, what's a coefficient? Well, it's these numbers out front. Sometimes I like to call them out fronters. I mean, that's really not what they're called, but it's basically synonymous. So it's these numbers out front. We don't add those. I didn't say that. I said when we have the same bases, right here is an x and right here is an x, then I add the exponents on those bases. Well, what do I do with those numbers out front? I would advise you to write them out front. Because multiplication can be done in any order, 2 times 3 is 6, and 3 times 2 is 6, I am going to take both of those numbers that are out front of the variables and pull them out front. And I'm going to rewrite this first. Then I've always known, well, at least since I was maybe 5 or 6, that 2 times 3 is 6. Notice I didn't add those. I didn't tell you add the numbers. I said when you have the same base, you add those exponents up. So this would be x to the 1 plus negative 4, which gives me 6 to the first and x to the negative third. And again, we don't leave any negative exponents in our answers. Keep in mind that 6 is to the first power, because that's not in parentheses, so it'd be 6 over x to the third. Next, we are rewriting these using each base only once. So basically I'm simplifying again. M to the third times n to m to the fourth, I keep that base and I add up those exponents. I'd like you to think, me as a teacher, is what mistake I see very often with one like this. And you can probably guess, I get a lot of times when I'm teaching exponents, kids do what looks good, they don't do the properties. So make sure you don't multiply those exponents, okay? When we multiply, we add the exponents. And think it out, don't memorize it. 3 of them and 4 more of them makes 7 of them, not 12. All right, next one up. Well, what exponent is this t to? It's to the first. And so we'd have t to the negative 5 plus 1, which gives us t to the negative fourth. And we don't leave negative exponents. We send them down to be more positive. Equivalently, we divide by t 4 times. The next one I know got cut off, but you should be able to see it in your notepad. Actually, I can probably move it over here a little bit. There we go. So what is my base on this one? It doesn't matter how ugly your base is. In this case, it's a negative 2. All of them are negative 2. So we have negative 2 to the first, negative 2 to the third, and negative 2 to the seventh. So notice I've kept that common base, and I'm adding up all the exponents. That gives me negative 2 to the negative third. And again, we don't leave those negative exponents, so what I'm going to do is I am going to take my base and divide by it 3 times. And you can put 1 over negative 8 if you would like to. So, moving right along here, flipping through this pretty quickly. We might not do all of these, but we'll sure do a few. So first one up, got the same base, I add the exponents. 8 plus 5 is 13, and it's done. What do I do with one like number 2? I take these coefficients, these outfronters, and I think of pulling them out front. And then I get my common bases all lined up and next to each other so that I can deal with this numerical part and then take my exponents and add them up. What is negative 3 plus 4? It's 1. Again, that 1 isn't necessary there on the exponent. What do these parentheses mean? This also means multiplication, and in this case, these are acting as grouping symbols. They're really not necessary there. This is a 13, and then I've got a 3. Those are my numbers out front, aka coefficients. I've got an x to the negative 8 and an x to the 10th. 13 times 3 has always been 39. It still is. Notice I'm not adding the coefficients. I'm saying when I have a common base, I add the exponents. And that one's done. We did one like this. On number 5, we'd add up all those exponents, giving us t to the 18th. I'd like to look at number 6 a little bit more closely, just so you are very careful again with how you work with negative numbers and negative exponents. This right here is really a negative number. You don't see it because it's a 1, and again, we've talked about that. You are 14 or 15 years old, there's a 1 out front and a 1 tacked on, but we don't actually count those. So really what I've got here is a negative 1 times f to the negative 8 times 4 times f to the 12th. Notice I've removed those parentheses. They're just serving as grouping symbols. And in multiplication, the order in which we do things does not matter. So I am going to do the -1 times 4 first. I'm doing the coefficients or the out fronters or those numbers out front. And then I've got a common base of f, and I'm going to add up those exponents. -8 plus 12 is 4. Now you might say, you said if there's a negative, it gets sent to the bottom. And this is where you have to be really careful with the details about what I'm presenting you today. And throughout this chapter, I did not say when there is a negative, it goes to the bottom or to the other level. I said a negative exponent. This is not a negative exponent. It's -4. You would never, if I ever said to you, what's -4? You would never say, oh, it's 1 over. No, it's not. -4 is a -4. However, x to the -4th, now that's a negative exponent. That'd be 1 over x to the 4th. So we're going to be really, really picky about our exponents and be very careful. What will I do with one like number 7? I've got common bases here. I've got an m, 2 more m's, and another m. And if I put in those invisible ones and add up those exponents, I've got 4 m's. I've got n to the 2nd, and then I'm down 4, so I'm at -2, and then I'm another -1, so I'm at -3. Again, I got myself a negative exponent here, so I've got to use a previous sections property that says that means to divide by n 3 times. We've done one like that. I think you would get that one. Let's go take a look at number 10. Number 10, I would advise you to stop this and pause it and try to do it on your own. And if you've got number 10 down, you are probably set to go, but I'm just going to continue on through here. But you pause the video and go try number 10 and see how you did. I'm going to take these numbers out front, and in my brain or physically on paper, I'm going to pull them out front. -3 times 5 is a -15. It's a negative number. It's going to stay put. Then I'm going to do c to the 7th, and I've got c to the -3rd, and when I add those exponents up, I get a 4. I've got a d to the -2 and a d to the 1st. And when I do -2 plus 1, I'm at -1. Again, we don't leave negative exponents. The exponent on that is actually positive, so the -15 is going to stay put. This c to the 4th is going to stay put, but this means to divide by d once. All right, moving right along to this last page here. When we're working with scientific notation, we're going to approach it exactly as I did on the previous page with the grouping. I'm going to ignore these parentheses. They're not doing anything for me. This is 5 times 10 to the 4th times 1 times 10 to the 7th. I am going to take my non-exponent parts, the 5 and the 1, and do them first. I know what that is. I'm going to do the 10 to the 4th and the 10 to the 7th second. This gives me 5. And this would give me 10 to the 11th. And then I have to ask myself, drawing from section 7.2, is this in proper scientific notation? And the answer is yes. A number between 1 and 10 times 10 to an integer. Interestingly enough, my daughter called me last night. She's working on some college chemistry, and she was doing some scientific notation. And even though she's gone all the way through pre-calculus, she had forgotten how to do division with scientific notation, so it does come back at you in other levels of math. So let's go take a look at number 12. We're going to pull those coefficients out front. We're going to take those powers of 10 and put them on the back. Make sure you multiply those first, and then we add our exponents. Next, you have to decide if it's a proper scientific notation. So this is not a number between 1 and 10. Well, if it says to put it in scientific notation, you got to tweak it. You've got to take that decimal, move it back 1. Remember what we said, you've got to counter-react that by moving the exponent forward 1. Because this is dividing by 10 by moving that back, so we need to multiply by 10, which would move the exponent forward. Because we don't want to change its value, we're basically just giving it a facelift. So this would give me 4.9 times 10 to the, now what happens when I move -1 forward 1? I end up with 0. Well, what's that? That's 1. So actually I could just say that's 4.9 when that one's all said and done. Down on the bottom here, a little bit of geometry. We'll just do number 14 and we'll be done. This video might cut out, so I might not get a chance to finish 14, but we'll see. Area of a rectangle is base times height, length times width, whatever you were taught. Now in this one, the video's going farther. On this one, the parentheses are serving a purpose because this is an addition. Again, I told you the order does not matter if it's all multiplication, but I've got an addition in there, so hopefully you'll remember from your 8th grade or linear algebra days that you need to distribute this in here. You need to do 4x squared times 3x squared, which gives me 12x to the 4th. Then I've got to do 4x squared times 2x, which is going to give me 8x cubed. So make sure you pay attention to those parentheses. Have a good night.